Okay, so here's my VDJ drawing. So in the germline of all IGs, you have 45 different V genes, 23 different D genes, and 6 different J genes. And so these can all do something called somatic rearrangement or somatic diversification to create lymphocytes. And those lymphocytes are only going to have one V gene, one D gene, and one J gene. And so this creates millions of different possibilities of lymphocytes that you can have. And that's why every lymphocyte has different receptors. So the enzymes in this process are going to create this VDJ, unique VDJs, by recognizing RSS, recognition signal sequences. And the most important part of RSSs are the spacer region, and the spacer regions are surrounded by a heptamer and nonamer. So the space regions can either be 23 nucleotides long or 12 nucleotides long. The V's are all going to have the same spacer, the D's will have a different spacer, and the J's will have the another spacer too. So it's either a 23 or 12 long spacer, and you'll be left with this and a lymphocyte. So you'll have 23 spacer, and then like a 12 spacer, and then a 23 spacer. This would be V, D, and J. So that's what it looks like in a lymphocyte. And then a recap this whole process. So the first step is RAG12 is going to recognize the signal sequences by that spacer region. It brings them together like this, and then the RAG12 is going to cleave the 5' end of the heptamer nearest to the VD, or to nearest to the V, sorry. So it's going to cleave it. You'll have a free hydroxyl group. The hydroxyl group is going to come down, and when the hydroxyl group comes down, it's going to bind right there. And that's going to leave you with a signal in and a coding in. The coding in is what we're worried about. The signal in is ligated with DNA ligase 4 to create a episome right here. And then, so the coding in is what I said we're worried about. It's a hairpin right here. That hairpin is going to recruit Q7080, which recruits DNA PKC, which recruits Artemis. Artemis was what creates most of our diversity. It's going to randomly come in here and cleave in 3 places, 1, 2, or 3. In this case, I cleaved right there. So Artemis comes in, it cleaves. And the DNA PKC, I didn't mention this, but it phosphorylates Artemis too. Not only does it recruit Artemis, it phosphorylates it. Artemis cleaves it. It cleaves right here. And so this enzyme called DNA polymerase mu is going to work right here. So it's going to put in a bunch of these things called P nucleotides. So you add in the P nucleotides, and you're left with this. So they're called P nucleotides. They create a palindrome, ACGT this way, ACGT that way. And then TDT is going to add in N nucleotides randomly. I drew squiggly lines because it's just total chaos. So you have these, this is what creates most of your diversity, these 3 steps of Artemis, P nucleotides, and TDT. So lastly, you're going to have DNA ligase 4 again come in, and it's going to bind everything together, ligate everything together to when you're left with a V, D, and J region. So this is in a lymphocyte. You're going to have 1 V, 1 D, and 1 J, and they're going to be separated by those P and N nucleotides that I mentioned, and that's VDJ recombination.